Hello, good morning, and welcome. We are Team Evolve. My name is Sam, and it's my pleasure to introduce our project to you this morning. A little bit of background about the motivation for this project. As I'm sure you're aware, our society is moving to being more green and environmentally conscious, and with that has come the introduction of the electric vehicle as a competitive option against traditional fossil fuel vehicles. Our sponsors at San Diego Gas and Electric have realized that there isn't the type of wide-scale adoption of electric vehicles that you would expect from a city like San Diego, and have enlisted us to create a project that gives consumers an interactive experience that is both fun and educational. Our project consists of two different parts. One is a software part where they've developed a video game to give users that fun interactive experience, as well as the hardware side where we've created a model city of San Diego that captivates people and brings them in to give them this great experience. And this city is modeled and navigates cars through the city based on user decisions in the game. First, we're going to start with the software side, where they go about talking about how they developed the video game. Then we'll move into the hardware and talk about how we realize this complex system. I'm going to pass it over to Plum to give you a software overview.
Thank you, Sam. Hello, everybody. Thank you all for being here. So, like Sam mentioned, our team Evolve is divided into two parts, hardware and software. Our software, the three main aspects, our software part has been working on all semesters, are the consumer survey, we have a vehicle data research, and we also have the video game, 3D video game.
As Pullman mentioned, we created a survey, and so we created a survey in order to create a good way for our video game for the user to interact. So our survey results come from a mixture of SDSU students, co-workers, and friends, along with SDSU business team, both projects which are sponsored by SDG&E. So the survey is composed of three sections. We have the general question section, car-related questions depending on what type of vehicle you have, and also car buying questions and a recommended car as well. So the way it works is that once the user finishes the survey, the results are then sent via email to our team's email address. And those results are gathered together in order to form fun questions that will be asked throughout the video game. On the left, we have a block diagram of how the survey works, and on the right, we have a screenshot of how the survey looks on our website. And here's a screenshot as well as how the fun question is incorporated in our video game. Now I'll hand it over to Izzy, who will talk about the research and statistics on how each car got their information.
Good morning. So we researched on on a wide variety of 4 different type of vehicles. We created this. We specified on the gas, hybrid plug-in, the hybrid, and the electric car. In order to build a unique car, we decided to have inaccurate research to develop our cars. That way, we created an algorithm to create how much the user would how much the user would spend, depending on what decision the user did. For instance, if the user decided to go on a city or highway, it would have a consequence for the decision that he made. So now I'm going to pass it to Daniel to talk about the vehicle selection.
Okay, so here we have the car selection scene where each user will select the vehicle they wish to use during the game. Each of the choices will have their vehicle type listed, such as hybrid, plug-in hybrid, electric, and gas. Each of the choices will also be given a price, a button associated with the game controllers, as well as various ratings. The purpose of the ratings is to inform the users of the realistic characteristics they can expect from each of the vehicle types during the game. When ready, and after each user selects their vehicle, the prompt will appear. A prompt will appear notifying the user to press start to begin the game. When start is pressed, the selected vehicles will successfully spawn to the main game scene, which was supposed to be here. Next, we'll have Antonio discuss about the story part.
Thanks, Sam. So basically, our video game consists of 5 different turns. The first one being the work mission, the next one the errand mission, the third one the family, the fourth the friends, and the last mission, which is a bonus round, is a road trip to Disneyland. So basically, the player gets 4 different decisions, and basically, depending on which decision the player makes, it could either have a negative or a positive consequence. So let's say if a player continuously chooses, oh, I want to go to work, despite that it's a Saturday, I want to maintain my vehicle, I want to go visit my grandma, then they're just going to have a positive consequence on the game. So as a result, the in-game multiplier is going to increase. And also inversely, if a player makes negative decisions like, oh, I don't want to see my grandma, I want to call in sick and go to the beach instead of going to work, then the in-game multiplier is going to go down. So if a player consistently makes bad decisions and doesn't really do so well, they'll have a chance to make up for their deficiency in points during the road trip, the bonus round road trip to Disneyland. So basically during the bonus round, the player is going to have the opportunity to answer 5 quiz questions based off of our survey data. And if a player gets a correct question, then they're going to score bonus points. So then at the end of the entire game, a player is going to see a summary based on their calculated 10-year period, like if they were to make these decisions over like a 10-year span, how much money they'd have left, and then their vehicle-specific rebates, and also their score multiplier. So then at the end, like finally, once the player is done playing the entire game, they're gonna have their points converted, their money converted into points, and whoever has the most points is gonna be deemed the winner. So next I'm gonna pass it on to Pat to talk more about the gameplay and the game environment.
Thank you, Antonio. And here is a brief overview of how the game environment looks like. To implement how the game works, we had to design a city first. So we implemented first all the buildings set up into a city, and there's several destinations that each car will go to. As you can see on the left, there's a start point where the car will actually start, and then choose a destination depending on where they want to go. As you can see here, this is the user interface. On left is player 1, on the right is player 2. Each has a fuel gauge. One has a battery gauge, which is the electric car on the right. And depending on their choice will be their consequences as well. They also have to press a button in order to go to the destination. If they run a red light, it says that, and their consequences will be affected. As you can see, the cars are driving to their destination right now. And as soon as they reach their destination, their fuel will be affected. On the left will be the gas car. It is reaching the beach right now. As you can see, the fuel just decreased by a certain amount of fuel. And now the car will end. On the right, it just head to work. And on the left, he went to the beach. And I'll pass it off to Zach to talk about how the waypoints work and how they get there.
Thanks, Pat. Good morning, everybody. So in order to control the cars and have them have autonomous movement, we use a system called waypoints, which are these yellow lines. And as you can see, we have waypoints all along the map. This is from underneath looking up. They control the movement from the start to wherever the destination is. And they act as rails in the software for the vehicles to move on. So they move smoothly across these lines as they get to their destination. These rails, or the waypoints, are what we use to begin sending data to the hardware side to control the map. And to talk more about that, I'll be passing it over to Leo.
Yeah, so these waypoints they represent the different tasks that the user can pick throughout the game on their turn. So at the beginning of the turn, The user will be prompted to pick one of the waypoints by pushing the corresponding button on the Super NES controllers we'll be bringing in. And then once they push the button, the waypoint will be set and the destination will be set in game. Once that happens, the game sends commands over to the hardware side, in which we let the track readjust so that the two paths in game and out of game match perfectly. Once that happens, the game then sends commands over to start the car in game and out of game. And then that allows the cars to traverse the city, get to its destinations, and complete its missions autonomously. Once that happens, the cars will then loop back to the starting point, and the user will be able to continue on with the rest of the turns. So the important part of this was we were able to communicate the path that the car will be taking in-game, send it over to the hardware, and then let their track adjust accordingly so that the paths line up. And to talk more about this communication between hardware and software, I'll pass it on to John.
Thanks, Leo. So our vision for the hardware side of the project was to mirror the video game as closely as possible. In order to do this, we had to build a small-scale city model complete with 2 moving vehicles, 1 vehicle for each player in the video game. The way the car goes around the environment and we make it move where it wants to move is via a magnet and rail system. Each car has a magnet underneath its front axle, which follows along a metal wire embedded in the track. And as Leo mentioned, we can turn different turns at the intersections via a servo. Now, the way the video game is controlling the hardware is via a USB to UART breakout board. Now, based on the exact command that the video game sends through to the master microcontroller, the master microcontroller has been programmed to send that off to the correct location, whether or not it's an intersection microcontroller or to talk to the car wirelessly. We also have an RGB detection system to keep track of where the vehicle is in the environment after each breakpoint. To talk more about the RGB detection system, I'll hand it off to Osmond.
Thank you, Jonathan. Good morning, everyone. So just as John mentioned, there will be 2 cars simultaneously running on the track. So it's an important part that we keep track of where they are and identify them. So before we could do that, we had to figure out how we could implement this. So we did this by using an RGB sensor. Before we settled on the RGB sensor, we tried out different forms of tracking, such as RFID, RF, and even placing smaller cameras throughout the track. But since the RGB sensor was most cost-effective and readily available, we decided to go with that one. So the particular RGB sensor we will be using is provided by Adafruit. It features an IR filter, which is an infrared filter, and a white LED. The implementation process can be split into 3 simple steps. First of which is figuring out if the RGB sensor works properly. The way we did this is by placing different colored stickers beneath the car, as you can see up there. We tried out different colors such as red, orange, yellow, green, and blue. And after running it over the sensor many times and using the color view program we were using, we analyzed RGB lux and color temperature values and figured out that naturally red and blue have the most different color values. So when identifying things, it's important for things to be different. So that's why we chose red and blue. The next step in the RGB process was to create a handmade I2C code that will mirror and mimic what the software side created in terms of traffic intersections and servo movements and starting and stopping of the car. We did this by analyzing the PIC24 microcontroller and RGB sensor registers and pin layouts. The last step in our RGB sensor implementation process was to figure out how to trigger the white LED on and off on the sensor. The reason why this was important is because this was a design constraint that was for us from our sponsor. So the way we did this is by placing a photoresistor a few centimeters before the RGB sensor. And so when the car drives over the photoresistor, it senses the darkness, and that's what triggers the white LED to turn on and off. This was very important because, as you'll see later on in the presentation, we have 14 of these spread amongst the track. So we need to figure out a way to turn them on and off, because if they're all on at the same time, the bright white LED is pretty blinding, so that would be unpleasant to look at. So that's what we did with the photoresistor, to turn it on and off at the right times. So now that we figured out that the RGB sensor works properly, the next step was to handle the vehicle hardware. And I'll now pass it on to Andrew, who will talk more about that.
Thank you, Osman. So as you can see, this is the final design of our car without the case on top of it. The whole entire car is run from a PIC microcontroller. On the top, it has an RF module that communicates back with the master microcontroller that John had mentioned before, and can receive commands to vary the speed of the car or stop the car. On the bottom, you can see the Hall effect sensor that's used to be able to detect magnets in the track to stop the car. We also used a 3.7 LiPo battery that is able to be charged through a micro USB port on the bottom of the car. For all these components to fit in such a small area, we designed our own custom PCB. And yeah, to pass it on to Justin, he's going to talk more about how the Hall effect works on Ford.
So for the car, we needed a way to stop it at the street lights when it came up to them. We decided to go with the Hall effect sensor and neodymium magnets mounted on the track. The Hall effect is always on, but in order to prevent it from just constantly stopping at the magnets, it works in tandem with the video game using RF communication to trigger it on, or to trigger the Hall effect to start looking for the magnet. And when it says it'll come up to a magnet and it'll stop, the video game, when the light turns green, the video game tells it to go, and it tells the Hall effect to stop looking for the said magnet. Next, I'm going to go ahead and pass it off to Ian to talk more about what the board is.
Our sponsors at SDG&E plan to use our project as a mobile demonstration unit that they can take to various locations and use to educate people about the differences between electric and gas and hybrid vehicles. That gave us a certain design constraints based on our size and weight. Our enclosure measures 30 inches wide, 20 inches deep, and 9 inches high. And it weighs a little under 50 pounds, can be easily moved by 2 people. The enclosure frame is made out of extruded aluminum rails, commercially available from 80/20. The top and bottom panels are plywood. All the side panels are compressed fiberboard. The inside of the enclosure houses a custom-built mini ITX gaming computer, power supply, and all of the electronic and electromechanical components required to make the track function, including 27 custom-printed PCBs, 35 individual microcontrollers. The track surface integrates all 14 RGB sensors and 10 servos for switching intersections. The enclosure itself integrates intake and outtake cooling fans, a master power switch with a 15 amp protection fuse, auxiliary power outlet for the display, and a on-off switch for the computer. The top track surface is built in 2 layers. The bottom layer already mentioned is the plywood. The top surface houses the actual track and everything on it. To talk more about that, Ryan will come up.
We wanted to make our hardware model as realistic and San Diego-like as possible. And we also wanted it to closely match the video game that our software side developed. In the slide you can see that we have our city split into 3 main sections that the car will drive through as it follows around the track. Those 3 sections include Balboa Park, a residential area, and a downtown area. On the next slide, you can see the building designs that we made, 3D printed and painted. These iconic San Diego buildings include the Museum of Man and the Botanical Garden in Balboa Park. We also included the Semper Building and the Downtown Library. We added solar panel parking lots, water effects, and numerous traffic signals to give the appearance of directing traffic flow. Next, Leslie's going to talk more about the SolidWorks behind this project.
Okay, so our track, we want to design it so there's 2 outer loops so we can have 2 cars going at the same time, and then one thing going through the middle representing the city, going home to charge, or also going to work to charge and get gas. So this is the design of the track. Underneath what you're actually seeing, where all the wires are inlaid into there that the car is going to be following. So underneath the track, we also had to have housing for the servos and the RGB sensors. So So I designed those. RGB sensor is going to be on the left. It's mounted perfectly against the track. They all have to be equal distance away from the track in order to get the correct reading. So that's why they're in specific housing. The servos are mounted underneath the track, and when there's a special arm that was designed so that the wire can lay into the arm as it's pivoting, which you guys saw earlier. We also needed to custom design a car body because we basically built the car from scratch. And that is that. Budget now is going to be Justin.
In order to provide the best possible project that we could, we had to get the best quality parts and items. As you can see, we spent quite a bit of money, most of it going towards the computer, but as it also said, we had 27 PCBs, we had a ton of microcontrollers, ton of different masters and slaves. So at the end of the day, in order to provide the best project, we had to buy the best components and the best items. Next, I'm going to pass it off to John to talk about our milestones.
So this project was planned from start to finish. In order to realize our goals for the hardware side, we broke it up into smaller functional blocks. Now, like any other project, we completed some of the milestones ahead of time, and we fell behind on some of the others. We ended up actually getting to the integration and testing portion a little bit later than we would have liked, but we're confident that we're still delivering a quality product to our sponsor, SDG&E. And I'd like to hand it back over to Sam for closing comments.
Thank you, John. So as you can see, this is a very intricate system, a lot of moving parts, a lot of communication. It's been a great experience for both sides of our team putting this together, and we're very proud to present our project to you today. We're excited that there's this great model city that will bring people in with iconic San Diego landmarks and then keep them there with a great video game where they'll be able to learn about the benefits of electric vehicle ownership. It's been our pleasure to present to you today. Thank you so much for your time.